today we're going to be using our new measurement tool to measure the volume of 1 base 10 flat, 2 base 10 flats, and 3 base 10 flats. So we already know one way to measure the volume of these is to do length times width times height. So we know that the length is 10, the width is 10, and the height is 1. So 10 times 10 times 1 is going to give us 100 centimeters cubed. Using this measurement tool, what you do is put base 10 flat in to our measurement tool, and we can see that the water has risen all the way to the 100 milliliter line. So that tells us that the volume of this base 10 flat is 100 milliliters. So you can go ahead and record that on your journal page 215 in the chart where it says number of base 10 flats. Next to 1, the volume in milliliters is 100, and the volume in centimeters cubed is also 100. So let's see what happens when we put 2 in there. So this time, the volume has risen up to the 200 milliliter line. So we know that we can put in the chart next to 2 that the volume in milliliters is 200, and the volume in centimeters cubed is going to be 200 as well. And the last base 10 flat that we're going to add is this third one. So let's see. When we add the third one, we see that the water rises to the 300 milliliter line, and that tells us that the volume of all 3 base 10 flats is 300 milliliters. So we can fill in that last section of our chart with 300 milliliters and 300 centimeters cubed. So the next question asks you to look at the table, and what do you notice? I notice that both volume in milliliters and volume in centimeters cubed are the exact same. So using that observation, I can answer on number 4 that 1 milliliter is going to equal 1 centimeter cubed. So now we're going to use this calibrated bottle to measure the volume of 3 different objects. So I picked a few household items that we can displace. I picked some sunglasses that we can displace first. So I would write sunglasses in my object section of the chart. Now I'm going to put these in here. I'm going to push it down. And it barely raises at all. I would say that's like 1 to 2 milliliters. And so I would write 1 or 2 milliliters in the first volume section, and then I would write 1 centimeter cubed in the second section. All right, another bigger object that I chose was this soap bottle. So I'm going to write down my soap bottle in my object, and then I'm going to stick it in here to get my volume. So I can see that the volume went up in between. It's almost to 500 milliliters. So I'm just going to go ahead and round up and say that the volume of this is 500 milliliters. And then it would also be 500 centimeters cubed as well. All right. Another big item that I found is some deodorant. So I'm going to write deodorant on my object, and then let's see what the volume is. So once I displace this, I can see that it goes up to the 200 milliliter line. So next to deodorant in the chart, I'm going to write 200 milliliters. And then since I know that the volume in centimeters cubed is the same, I'm going to write 200 milliliters there as well. The next question says to do a small object. So I have this Sharpie that I was using to calibrate my bottle. So I'm just going to figure out what this is in volume. So this barely raises up as well, just like the sunglasses did. So I would say that that's about 1 milliliter as well. I've noticed with the smaller objects that I don't get an exact measurement for my volume. So displacing one object might not give us a precise measurement because this was all done by hand and there aren't little tick marks in the middle to be able to give us that exact measurement. So this is sort of like an estimate for our volume.